This is the continuation for section 7.1, where prior to we learned how to write formulas of ionic compounds from their names, and now we're going to do the reverse. We're going to write the name of the ionic compound based on its formula. For example, given the formula Al2SO43, you should be able to tell me that the name of this is aluminum sulfate. These are going to be relatively easier than the reverse. However, it can be tricky when the metal is a transition metal, which will require a Roman numeral to identify which oxidation state it's in. And don't worry about oxidation state, is just a fancy name for the word charge. So you will have to tell me what the specific charge is on each transition metal. All right, how are we going to do this? We've got two steps to learn. First, how to uncancel or unswitch the charges, and then how to name the cation and name the anion. And we'll answer questions like, why are there 2 aluminums and 3 sulfates? And do the subscripts have an effect on our name? So first we need to understand how to uncancel and unswitch. We'll start with uncanceling. Remember that there is a pattern on our periodic table. So I have kind of a periodic table here on the right. And notice the transition metal section has been cut out because it is not part of our pattern. The pattern is group 1 will have charges of +1, group 2 will have charges of +2, group 3, which only includes aluminum, will have a charge of +3. We skip group 4, group 5 -3, group 6 -2, group 7 -1, and none for the noble gases because they're not generally involved in bonding. So how to uncancel? My first example is NaNO3, and so notice that there are no parentheses here. I've got two parts, the cation, which is the metal that always comes first, and the anion, which is going to be the nonmetals or the negative portion, which comes last. So what you need to realize is where the dividing line is in this compound. Sodium is your cation, and nitrate, NO3, is your anion. Because I have one of each, because I have one of each implies I have a 1-to-1 ratio. So I have 1 sodium to 1 nitrate. That means that we must have canceled the charges. So I need to figure out one of the charges in order to know the other. And hopefully you know the charge for nitrate, but if you don't, this is a great way to figure it out. Sodium is found in group 1, which has a +1 charge. So the sodium had a +1, and if the charge is canceled, then the nitrate must be a -1 charge. And so this is how I can uncancel the charges. Let's look at another example, magnesium and CO3. First, you need to divide it up. Where's the cation, where's the anion? Here's my cation, and there's my anion. Magnesium on the left, CO3 on the right. I need to uncancel the charges. Again, this is a 1-to-1 ratio. There is 1 magnesium to 1 carbonate. How do I know that that's only 1 carbonate? If I had more than 1, it would be in parentheses with another number after it. So 1-to-1 ratio, I'm going to find the charge for magnesium, which is right here. It's in group 2, so that gives it a +2 charge. And since they canceled, because I have a 1-to-1 ratio, the carbonate, or I'm sorry, the CO3 must be a -2 charge. So hopefully you know that your ion for carbonate is CO3 -2, but if not, this is a good trick to figure it out for the test to come. Okay, the third one is a little trickier because copper is a transition metal. Notice it's not in groups 1, 2, or 3. It's found in the middle, and we can't tell those charges by looking at the periodic table. So first, let me draw my dividing line. There it is. Copper is my cation, and the rest of this is my anion. In this scenario, we need to realize we have 1 copper and we have 1 of this anion. So it is a 1-to-1 ratio, and the reason you know that this is only 1 anion is because it's not in parentheses. If it were in parentheses, then we'd have more than 1. So this is a 1-to-1 ratio. So I need to know the charge of one of these two. I can't figure out copper, so I better know the charge for C2H3OH2, which is called acetate. The charge on acetate is -1 based on our list of ions, which means the copper must be a +1 charge. And so that's how I'm going to know the oxidation state or the charge of my transition metal copper. Let's try one more. We have Cr, which is chromium, that's my cation, and oxygen, which is my anion. Notice chromium is one of the transition metals. It's not found in my 3 columns, so I don't know the charge for chromium. But I do know this is a 1-to-1 ratio. So that being said, if I can figure out oxide's charge, then I will know chromium's charge. Oxide is here, and it has a -2 charge. So if that's -2, the chromium must be +2, so that they could have canceled to give me a 1-to-1 ratio. All right, let's look at unswitching for a moment. And I'm going to move my periodic table over to this other side. And I suppose I should erase that first so it doesn't show through. All right, unswitching, which is what we're going to do this time. This one is actually considerably easier than uncanceling because we have numbers given to us. The only difficulty is going to be when we have a polyatomic ion. So we need to identify our divide. Where's our cation? Where's our anion? And I'm going to go ahead and divide up each one of these really quickly. So here's my cation. The rest is my anion. The second one, I have 2 aluminums, I have 3 carbonates. The third one, I have 1 iron, 3 hydroxide. And the fourth one, I have 3 coppers and 1 phosphate. So now I'm going to go and identify the ratios. I have 2, oops, meant to draw that at the bottom. I have 2 sodiums to 1 sulfite, sorry. And this, if I had more than one, it would be in parentheses, like this one. So since it's not in parentheses, I only have 1. It's a 2-to-1 ratio. I'm going to unswitch to get my charges. This one means that sodium is +1, which we know because we can look at our chart, the periodic table, where sodium is located. And this 2 lets me know that sulfite is a -2 charge. And so now, after I have unswitched, then I can go ahead and name the compound. Here's aluminum and carbonate. This 2 means that carbonate must be a -2 charge, and this 3 down here means that aluminum must be a +3 charge. So again, we have a 2-to-3 ratio, and if we unswitch them, that tells us what charges we have. Remember that your cation is always positive, your anion is always negative. Cation, anion. Positive first, negative second. All right, this one, we have a 1-to-3 ratio. That lets me know I have 3 of them. So if I unswitch these charges, I have a +3 on iron and a -1 on the hydroxide. This is how I'll know it is iron 3 hydroxide. Last one, I have a ratio of 3-to-1, letting me know that the copper must be a +1 and this phosphate must be a -3 charge. So now that we know how to uncancel and unswitch, we can learn how to name them. And all you do after switching, uncanceling or unswitching, is you name the cation, you name the anion. So in this case, if I uncancel them, I know sulfate is -2, which means copper must be +2. So the name of this is copper 2, that's my cation, and sulfate, which is my anion. My other example is iron 2 phosphite. Here is my iron. Because of this 2, that means the iron must be +2. Because of that 3, that must make this charge a 3. Iron +2 is called iron 2, and the PO3 with a -3 charge is called phosphite. In our next video, section 7.1c, we'll put all the rules together and practice.